Bismillahirrahmanirrahim. My name is Architect Mariya, and today is 8th of April 2020. And I am actually here to present you one of my presentation. And today I conducted my mock midterm exam with the students. Three of them did not yet able to appear in the paper and accidentally due to some personal issues. I don't know exactly. I just talked with one of the students and he was facing some technical error from the server part, or I don't exactly know. But let's start with our topic that will be shared, and this link will be shared with you after your midterm exam. And let me present you my entire screen so that you may get able to understand today's lecture. So, students, we have been talking about the solar geometry in our subject. It could be called as environmental control system or the thermal comfort. As an architect, we can use both of these things. I have already told you about problem with the sun. We have studied about how to use free solar energy for our benefit. We have talked about all these topics, and we have not done with passive and active means of architecture. Architectural design. We'll be talking on it later on with the brief presentations, and then we discussed that why the solar geometry is important as an architect. What is the importance of solar geometry in our field? So then we proceeded towards different time zones and different solar noons. We discussed about the solar position. We talked about the spring equinox, fall equinox. We talked about the solstice and summer and winter solstice. And then, importantly, we talked about that how the seasons actually get changed according to the solar system. And I told you very briefly about then how the seasons appear. I'll be showing after this presentation you guys with three of the links. I'll be showing you those videos with my lecture too, so that you may get able to understand, to grasp whatever I'm going to teach you. And in that, I'll be including that how the seasons actually change according to the schedule, according to the I'm sorry, according you can say it according to the climatic condition which is being happening in our solar system. And then, importantly, we talked about that during summer solstice, the sun is directly overhead on the Tropic of Cancer, and during the winter solstice, the sun is directly overhead on the Tropic of Capricorn. And I have already told you about what is the Tropic of Cancer, what is the Tropic of Capricorn. It's 23.5 above the altitude of the equator and below the altitude of the equator. And then we talked about what are the different resources which can actually create a hindrance between the sun rays towards the rays which are coming towards our earth, and that could be reflected, that could be scattered, there could be another and a lot of other reasons. Then we discussed about the rays which are in oblique angle and the rays which are falling on our earth as in perpendicularly. So we decided that the perpendicular rays will be affecting more to our sun rather than these oblique angle rays. And these are the different views of the oblique angle falling on our earth on the different places. I have taken another picture for you guys to understand according to the mathematical diagrams. Then how the tangent angle and how the sine angle affect on our buildings. And then we talked about the diffuse light and the direct lighting in our environment, and how can we actually incorporate into our interior the sunlight, what could be the benefit of such type of lighting. And these are the different conditions of the skies according to the direct rays, and these are the diffuse. This is the diffuse one, and this is the direct lighting. You can easily see the direct light is creating somehow of shadows. You can see in this picture too. The dark and the intense light and the direct light is creating some darker part of that room, and on the other hand, diffuse lighting is creating the whole room as enlightened. Same in this condition, you can see easily. So, in all of these buildings, in all of our world, in our surrounding, we have never been focusing on this issue, which is very important as an architect to study, that how we can actually play with the sunlight in our buildings. And I talked about reasons for the winter. We talked about the different definitions of latitude. Latitude are the horizontal lines, and longitude are the vertical lines parallel to the equator. Equator is this line, and over here, equator is this line. We just assume this is equator, but on the other hand, this is the international date line, that is our prime meridian. And then we talked about solar position of the sun on this envelope is called as solar position. So we identify the solar position according to three angles. One of those is solar altitude, another one is solar azimuth angle, and third one is the zenith angle. So you can easily grasp through the picture that what are these different angles. And I've already given you a brief about these three angles, how we can identify these three angles. And this is the solar altitude, azimuth, and the zenith angle. On the other hand, will be this angle with a perpendicular. If we place a stick over here. So this is another example of same definition. You can easily grasp with all these examples. When we talked about solar position, I already explained you about the solar window. A solar window is a window in which we have the maximum rays of the sunlight falling on our Earth, falling on our solar envelope. And then we talked about sky dome. Sky dome is an imaginary dome around our ball. If its horizontal plane is our ball, this envelope will be called as sky dome, and on which we actually identify the solar position and position of the sun on different timings. And these, let's come towards the point where I want you to come, and these are the different projections. You can easily see that. Horizontal projection sun path diagram are these, and you can easily see the sky dome projected onto horizontal plane. We are actually having the different perpendicular of the sky dome on this horizontal ground, which is our Earth, and the circle shows the altitude. These circles will be showing us the altitude of the angle, and these radiating lines shows us the azimuth angle. The sky dome, then we'll be coming towards another picture. These are the azimuth angles. We are taking the projection of these lines in these circles. And these radiating lines, as I have showed you, these are the azimuth angles. So this is the derivation of horizontal and vertical sun path diagram. We'll be taking the vertical projection of the sun diagram. I'll explain you later on if you guys do not get able to understand or to grasp the picture. These radiating lines are called as azimuth angles, and these circulating lines are called as altitude angles. And then we have the sun path diagrams again, and these are the different sun path diagrams. We have already explained about this is the summer angle, and this is the equinox sun path, and this is the winter solstice. And you can easily find out all these sun path diagram of the different areas of the world on this website. This is another picture of the sun path diagram. So I'll be going towards one of the videos. I'll obviously share you with you guys later on. Let's talk about reasons for the winter firstly, and then we'll see towards
When I was a kid, my understanding of the seasons was that December and January were cold and covered with snow. April and May were bursting with flowers. July and August were hot and sunshiny. And September and October were a kaleidoscope of colorful leaves. It was just the way the world worked, and it was magical. If you had told me back then that 1/3 of Earth's population had never seen snow, or that July 4th was most definitely not a beach day, I would have thought you were crazy. But in reality, seasonal change with 4 distinct seasons only happens in 2 regions on the planet, and even in those 2, the seasons are reversed. But why? A lot of people have heard of an astronomer called Johannes Kepler and how he proved that the planetary orbits are elliptical and that the sun is not the center of the orbit. It was a big deal when he figured this out several hundred years ago. His discovery solved a lot of mathematical problems that astronomers were having with planetary orbit measurements. While it's true that our orbit's not perfectly circular, those pictures in our science books, on TV, and in the movies give an exaggerated impression of how elongated our orbit is. In fact, Earth's orbit is very nearly a perfect circle. However, because Earth's orbit is technically an ellipse, even though it doesn't look like one, and the sun isn't quite exactly at the center, it means that our distance from the sun does change through the year. Aha! So winter happens when the Earth is further away from the sun. Well, no, not so fast. The Earth is actually closer to the sun in January than we are in July, by 5 million kilometers. January is smack dab in the middle of the coldest season of the year for those of us up north. Still not convinced? How about this? Summer and winter occur simultaneously on the surface of our planet. When it's winter in Connecticut, it's summer in New Zealand. So if it's not the distance from the sun, what else could it be? Well, we need to also know that the Earth doesn't sit straight up. It actually tilts. And that axial tilt of the Earth is one of the main reasons for the seasons. The Earth spins on an axis that's tilted 23.5 degrees from vertical. At the same time, the Earth revolves around the sun with the axis always pointing in the same direction in space. Together with the tilt, the spinning and revolving causes the number of hours of daylight in a region to change as the year goes by, with more hours in summer and fewer in winter. So, when the sun is shining on the Earth, it warms up. After the sun sets, it has time to cool down. So in the summer, any location that's about 40 degrees north of the equator, like Hartford, Connecticut, will get 15 hours of daylight each day and 9 hours of darkness. It warms up for longer than it cools. This happens day after day, so there's an overall warming effect. Remember this fact for later. In the winter, the opposite happens. There are many more hours of cooling time than warming time, and day after day, this results in a cooling effect. The interesting thing is, as you move north, the number of daylight hours in summer increases. So Juneau, Alaska would get about 19 hours of daylight on the same summer day that Tallahassee, Florida gets about 14. In fact, in the summertime at the North Pole, the sun never sets. Okay then, it's all about daylight hours. I've got it. Well, no, there's another important piece to this puzzle. If daylight hours were the only thing that determined average temperature, wouldn't the North Pole be the hottest place on Earth in northern summer? Because it receives 24 hours of daylight in the months surrounding the summer solstice. But it's the North Pole. There's still icebergs in the water and snow on the ground. So what's going on? The Earth is a sphere, and so the amount of solar energy an area receives changes based on how high the sun is in the sky, which, as you know, changes during the day between sunrise and sunset. But the maximum height also changes during the year, with the greatest solar height during the summer months and highest of all at noon on the summer solstice, which is June 21st in the northern hemisphere and December 21st in the southern hemisphere. This is because as the Earth revolves, the northern hemisphere ends up tilted away from the sun in the winter and toward the sun in summer, which puts the sun more directly overhead for longer amounts of time. Remember those increased summertime daylight hours? And solar energy per square kilometer increases as the sun gets higher in the sky. So, when the sun's at an angle, the amount of energy delivered to each square of the sunlit area is less. Therefore, even though the North Pole is getting 24 hours of daylight to warm up, the sunlight it receives is very spread out and delivers less energy than a place further south, where the sun is higher in the sky because it's more tilted toward the sun. Besides, the North Pole has a lot to make up for. It was cooling down without any sunlight at all for 6 months straight. So, as the seasons change, wherever you are, you can now appreciate not just the beauty of each new season, but the astronomical.
So, students, you have easily seen that how she explained about we can determine the position of the sun on the earth and how easily we can identify why actually seasons are changing in our surroundings. Now let's come to the point which I wanted you to understand the position of the sun, how we can actually identify the position of the sun I told you about that we can identify the position of the sun by a practical, this is called sun peg diagram. And we can identify the position of the sun by the altitude. I've explained you that these lines, the circular lines, are called as the altitude angle of the sun, and these radial lines radiating from the center are called as the azimuth angle. And you can see on in this picture too. And these are the different other examples. And I wanted you to understand about that why we need to identify the position of the sun. I'll be explaining you later on this by end of this presentation, but let's talk about that how we can identify the position of the sun. I'll show you a practical example. If we could have been in university, I would have done a practical with you guys from 8 a.m. to 3 onward, and that would have given us such type of diagram. These are the vertical projections, a vertical sun path diagram, and you can easily grasp this could be the winter on 21st of December, and this is on 21st of June. So this is a summer solstice, and this is the winter solstice, and in between of this we have the March 21 and 21st December, which is called as equinox, when we have the days and nights which equal. And we can easily grasp that how the vertical projection have been taken from this picture. As an architect, you know that we need to take some elevational lines, some projecting lines from the sun position. If the sun is over here, we can easily project this over here, and by taking that we can make such type of the lines, these vertical lines. You can easily see we over here we have these altitude angle, and these are the southwest and east poles. This is how they actually take it. We can take the projection of these lines onto this paper, and we can mark this over here, and we can mark from this part to this, and this will be taking as this line. These lines will be taking and the winter vertical projections of the sun path, and these are the equinox vertical projection of the sun path, and this is the summer solstice vertical projections of the sun path. And this is another example of the picture, and these are the different examples of the different areas you can easily grasp. I will actually mark, I will send you some of the diagrams like this. I'll send you these diagrams which are actually taken on some of the country around the world. I'll surely show you some of the examples so that you may get able to draw these things. You can easily draw this by compass, by using a paper, by using a pencil and the compass. You can draw these lines on a paper, and you need to draw these different timings, and I'll show you that how you can obtain these lines and these points. When you'll see the video, I'll show you. And these are some of other example for horizontal projection sun path diagram. And this is for a country with which to you can identify it on your Google map or somewhere over where we have the longitude is this and latitude is this. And this is the Toronto latitude. The architect or the explanation have been given for by the viewer is here. And I will send you for the plan for the Lahore. And these are other examples. Now let's talk about how we can actually identify these lines. Parabolic lines. These are. This is rectilinear sun path chart. And these are the sun peg diagram. I told you earlier that we'll be performing the sun peg practical in our university. Let's talk about the sun peg diagram, how we can actually identify that one.
Hey everybody, Jeff here with Martin Survival. So today I'm going to show you a quick navigation tip called the shadow stick method. Now this was used in early primitive culture, and it's still used today by lost hikers and adventurers who end up getting lost in the wilderness and find themselves in a survival situation. This method will help you find north, east, south, and west. Stay with me and let me show you how to do this. You're going to need one stick about 3 feet long. You're going to need another stick that's about 3.5 feet long. Then you're going to need markers. Now you can use branches as seen here. These are just pine branches that I sharpened at the end, or you can use rocks. And the last thing you're going to need is, of course, the sun. So the first thing I want to do is take the 3.5 foot stick and just set it to the side here. And what I've done is I took the 3 foot stick and just sharpened it at the tip, so it's easier to work it into the soil. And what I want to do is I want to take that sharpened end, put it on the ground, and I want this stick to be straight up and down. I don't want it to be leaning to the left or right, back and forth. I want it straight up, and I just want to hammer it. In this case, I just have a stone here into the ground so it's nice and tight. Just want to check things, make sure it's nice and straight once again. Okay. Now when you do this, you want to make sure it's in a nice open area to where there's no shade. And you also want to make sure the dirt is nice and smooth. And I'll show you why in just a second. So now I have my stick that's straight up and down, as you can see here. And the first thing I'm going to do is I'm going to go ahead and take one of my pine branches that I went ahead and shaved off. And I always start with the larger pine branch. And I want to take that and I want to follow the shadow that's casting off this little branch here. And I want to mark it at the end. Now what that's going to do is that's going to lay my first marker for navigation. So I'm going to find that. And I'm just going to stick that into the ground right at the tip. So as you guys can see, the bigger stick casts the larger shadow. And then at the tip, the smaller stick also casts another shadow. And one way to tell that this is a line is it'll all look like one shadow and it'll be straight in the center. And what I mean by that is a smaller stick's shadow will be straight in the center of the larger stick. Now everybody knows that the sun rises from the east and sets in the west. So what you're going to do is you're going to wait every 10-15 minutes, and once the shadow moves, you're going to mark it with another stick. So your first stick, since the sun rises from the east and sets in the west, your first stick is going to be your west point. And then your last stick is, of course, going to be your east point. So earlier I talked about having a nice flat surface and also being in the open to where there's no shade. And now I'm sure you can see why. And the reason why, well, you want that line to be very straight. And if there's a lot of ripples on the floor, if there's a lot of rocks, that's not going to give you true east and west, because that stick's shadow will be shifting. And I say use these little stakes here I carved out of pine for a few different reasons. Well, that's going to give you a precise shadow casting straight from the larger stick. And that's going to be able to mark it a little bit more clear, and it's also going to give you precise direction. Also, I can use this for other things as well. I can use it as a toothpick if I have something caught in my tooth. if there's a scorpion to pin down its tail, I have a stick here that also has an end to where I can hold that tail down and I can get a nice clear cut. Also, if I have a fire built around me and all those charcoals are still smothering somewhat, I can take this and use it as a writing utensil by smothering it in that charcoal and writing on a piece of wood or a piece of paper. This is very handy, and I recommend keeping a few of these inside of your backpack and scouting kit. All right, so that'll be the last.
So students will be finding out different positions of these sun pegs according to the sunlight. But this was another example that this guy is actually going to find out the north, east, and west side of this location. But what, as an architect, our part is we need to find out the position of a sun. So if we consider this practical at 8 a.m. and at 3 p.m., that makes a very sharp angle changes. We can do in between them, and we can change. We can make it out for 1 hour, for example, at 8, at 9, at 10, at 11. So at that time, we'll be finding out that we have such type of images. The images will be showing in this way. The images will be showing in this way. You can easily grasp from this video. Let me show you another example that will be very shorter one. You can
The apparent path of
I'll be explaining you can check it easily. Let's start it from here. You can see the longer angles and then the longer angle again. The sun path moves from this to this. You can easily see it again. Please check it. Starting from here and then this point. So this is what I wanted you to practically done with me in university. So these are the this is a sun path diagram, and as an architect we need to know about the north sign. Architects do not mention about north, east, and west side. We just mention about the north sign, and automatically we can grasp that where is the east and where is the west sign. This is a representation on our sheets or on our architectural sheet, that how we are actually going to um, idealize our site, because north sign, as an architect we use a north sign because on the north side we have the maximum benefit, we have the minimum energy loads. So that's why we use actually the north sign. So why we are actually going to study this solar geometry, and why we are actually going to going to do this practical, this is very important thing. So let's come towards that point. As an architect we need to conduct, I will be coming back to these slides later on. Let's talk about what is importance of these slides. So students, the importance of these slides are, the importance of the solar geometry is basically when we start any type of the project, we need to work on the site analysis sheet. And the site analysis means we need to conduct such type of study on our site, that from where sun is rising and from which path is it moving across our site on the different timing. For example, at 7 a.m. it's over here, and at 5 p.m. it is over here, and where the sun is going to get settled down. So when we actually start any of the project, we need to go for the site analysis. And in site analysis, we need to know about the sun path of that site, and we conduct such type of the site analysis. For example, the X marks the spot of the existing on-site sun projection. Look for the site shrouded by trees on west side. In this example, trees are on upslope, enhancing their shading ability. Don't sacrifice winter southern exposure though. So when we go for the sun path, we need to know about the shadows of the different objects. We need to know that where are the maximum heat load. We need to know that where we have to give certain spaces, certain important spaces of our buildings. So this is another example, how we actually give such type of the overhinges, such type of the angles on our rooftop on and in another slide which I will be showing you uh, with you guys in my on my live session about the solar strategies, shading strategies, and how an architect need to control the shading strategies, control the heat to coming inside our houses. So this was all about the objective to study. If you guys have any type of a question, you can ask me. And let's move towards the site analysis sheet I was talking about. So site analysis is a vital step in the design process. I want you guys to know about what is a site analysis. So when you get to know about the site analysis, then you'll know about the importance of the sunpar diagram in our field. So site analysis is a vital step in design process. It involves the evaluation of an existing or potential site in relation to the development of program, the environmental impacts on the community, adjacent properties, project budget, schedule, environmental constraints and opportunities. It is about development and constraints opportunities. So a well-executed site analysis forms the essential foundation for a cost-effective, environmentally sensitive, and rational approach to project development. Analysis of building program and ability of the site to accommodate it combined with assessment of political, environmental, and regulatory issues reveals the development potential of parcel of that land. That shows that what is importance of site and analysis in our project. We cannot proceed without the development of program. Development of program mean the development of the design process. And environmental impact mean that how different sun angles are going to affect on our site, how wind is going to affect on our site, and what is importance and what importance of impact of our site in our community. What are the different street views? What are the vistas and how this building is going to put an impact on our building. For example, in my second year studio, we are going to design a salon quite near to Mall of Lahore. So I'll be showing you the impact of that salon or impact of Mall of Lahore on that building. That is how we study about the importance of that project or we generate the feasibility of the project. So adjacent properties mean that what are the different facilities we need to develop while developing a project and a project budget. The most important thing is how much is the budget from the client side for your project. And then another thing is schedule, that how the project is going to get handled, and then about environmental constraints and opportunities. That what are the sun angles, what are the different sun angles in different seasons, and how we are actually going to handle these sun angles according to our constraints and opportunities. For example, if we do not want to have the flat roof in the hall and we want to put up the slopy roof over here, so what will be the opportunities and what will be the constraints to handle all these things? And then last but not the least, developmental constraints opportunities. This relates to what is required part of the project. So why is it required? Site analysis services. We are talking about site analysis, and I'm giving you the brief about that why we actually study the sun angles, and I related with my solar geometry with site analysis, and then now I am talking about site analysis part, which you will be doing in your second year design studio for the design part. So these are the different importance of a site analysis sheet for you guys as an architect, that why we actually conduct site analysis. And then let's talk about why does one need a site analysis? One may have defined a building program and in search of a site, or one may have selected a site and be interested in fitting a development program. So you guys will need to focus on this point. Of that site. For example, if you do not have idea about the sun path diagram, if you do not have the idea about that area's wind direction, if you do not know about the rainfall of that area, we cannot identify the fitting, that how we can fit that program into that site. So, in yet another case, one may have site and programming in hand and be seeking the most efficient, economical, and environmentally sensitive approach to site development. So, for approaching towards environmental sensible approach towards the site development, we need to know about the Sampad diagram. So, these are the different important things. I'll be sharing my these things with you guys, and these are other things you can see, but these are not related with my with my thermal comfort program, with my thermal comfort subject. This is related to the design part. But what I wanted you guys to know about that the importance of the sun path is over here. Navigation means we need to know about sun path and wind direction. We need to know about the temperature, average yearly temperature, average monthly temperature, maximum and minimum temperature range through the seasons. For example, if we want to study, we want to study about the Lahore temperature, we can easily imagine that what type of the building we are going to design over here. And on the other hand, if an architect going to design a building in Murray or in hilly area, so there will be the different charts for the temperature and the average monthly temperature and maximum and minimum temperature throughout the year for these two different areas. So is it a heating or cooling climate? For example, if it is Lahore, it's a heating climate. And if it is Murray or somewhere in the Quetta, we have the cooling climate. Should solar heat gain be maximized or minimized? That is identified by the solar position, that is identified by the climatic condition of that area. Then, importantly, wind direction, intensity and direction through the year. And wind direction may vary from place to place, inside to site, and thus should be checked from a few different places, especially if the site is large. If we have a very large site, we need to know about the different points of that area where we actually going to develop different things. For example, the parking lot and our main building part, the different adjacent services to that building. We need to know about the different points, and then we'll be studying about the wind direction on those specific A, B, C, and D points. And importantly, relative humidity or the humidity and precipitation and hydrology. This is important where we have the precipitation. For example, Murray in northern and hilly zone, we have the precipitation. So we need to know about the average annual rainfall. We need to know about the peak hourly rainfall. We need to know about the spread of rainfall, drainage pattern of the site, location of the water bodies, depth of the water table, quality of the ground table, and highest floor level. So this is how we conduct about our site analysis regarding the climatic components and regarding the different factors which is affected on our site. This was example number one. This is another example when you will be doing your design in your second year studio. That will be easy for you guys to grasp. But what is the importance of the standby diagram? I was telling you about that. So this is all about my today's lecture. If you guys have any of the questions, but usually people do not ask the question. But if you have any question, you can ask me or you can contact me on my contact number, which is 0300 or on my Gmail account, that is isawaishwa.javeria, at the rate of usa.edu.pk. So thank you guys for listening me. And all the best for your papers. And most importantly, stay home, stay safe, and take care of yourself, take care of your families, and be a good listener. Keep working at home with your studies. Please get aware about that. We, on behalf of our university, going to make your academic platform very strong with these online sessions. And thank you so much, University of South Asia, for providing us this platform. And thank you so much, student, for listening me. So all the best for your midterm exam. And I'll be sharing you this link on my platform. Thank you so much. Allah Hafiz.